Hello everyone, welcome back to our course on electrochemical processes and applications. This is our second lecture and today we will be learning about how to write a reaction in electrochemistry. In this lecture we will learn about the basic steps that are involved in writing a chemical reaction or an electrochemical reaction in a simplified way. Then I will explain you some of the examples and will show you how to write an electrochemical or a chemical reaction stepwise. Writing an electrochemical reaction is not a complex task. If you follow these 4 steps, you can easily write an electrochemical reaction. So these 4 steps are: first, balancing the metal atoms. Then you have to balance oxygen with water. Because you are adding water in balancing the reaction, it means you are also adding hydrogen. Then you have to balance hydrogen by adding protons, that are hydrogen plus ions. At the end, the last step is balancing the charge with the addition of electrons. Now I will show you some example by following these 4 steps how you can easily write an electrochemical reaction. Now I am showing you some examples. In these examples, you will see how to write or how to balance an electrochemical reaction in a simplified way. We will follow the 4 basic steps as we discussed earlier to balance an electrochemical reaction. So the first example is about the conversion of Fe2 plus ions into Fe2O3 species. The first step is about balancing the metal atom. As you can see, we have 2 iron atoms on the right side of the reaction. We have to multiply ferrous ions with 2 on the left side. The second step is balancing oxygen with water. As you can see in the above reaction, we have 3 oxygen atoms on the right side of the equation. It means we have to add 3 water molecules to balance 3 oxygen atoms in the Fe2O3 species. So we added 3 water molecules on the left side. Due to the addition of water, we also added 6 hydrogen atoms in this reaction. Adding protons to balance hydrogen is the next step. So we added 6 hydrogen ions on the left side to balance 6 hydrogen atoms, which we added by adding 3 water molecules in the second step. The final step is about balancing the charge with electrons. As you can see, we have plus 4 charge on the left side of the equation and plus 6 charge on the left side. So we have to add 2 electrons on the right side to balance charge on both sides. As you can see, by following these 4 steps, you can easily balance an electrochemical reaction, as highlighted at the bottom. The next example is about the oxidation of ferrous ions into ferric hydroxide. As you can see, here balancing the metal atoms on both sides is our first step. We have 1 iron atom on both sides, then it means you don't have to multiply with any number. The second step is balancing oxygen with water. If you can see on the right side, in ferric hydroxide we have 3 atoms of oxygen. We therefore added 3 water molecules on the left side in step 2. In step 3, we have to balance hydrogen with the addition of proton. As you can see, we have 3 water molecules that contains 6 hydrogen atoms. That is why we have to add 3 hydrogen ions on the left side, because in ferric hydroxide we already have 3 hydrogen atoms. So on both sides, hydrogen is now balanced with the addition of 3 protons. Finally, in the fourth step, we have to balance charge with electron. As you can see, we have +2 charge on the left side and +3 charge on the right side in step 3. It means we have to add 1 electron on the right side to balance overall charge of this reaction. So finally, you can clearly see at the bottom that the electrochemical reaction is an oxidation reaction in which ferrous ions are being oxidized to ferric hydroxide. By following these 4 steps, you were able to write a balanced electrochemical reaction. The final example is about the conversion of ferric ions into ferric hydroxide. As you remember, the first step is checking the number of metal atoms on both sides. In this particular reaction, we have 1 iron atom involved on both sides. Therefore, there is no need to balance iron atoms. The second step is about balancing the oxygen with water. As you can see, we have ferric hydroxide in which 3 oxygen atoms are involved. Therefore, we added 3 water molecules on the left side of the reaction. The third step is about balancing hydrogen with protons. In ferric hydroxide species, we already have 3 hydrogen atoms and we added 6 water molecules on the left side. Therefore, we have 3 additional hydrogen atoms on the left side. To balance hydrogen, we added 3 protons on the right side of the reaction. Now hydrogen is balanced in step 3. In step 4, you have to check about if the charge is balanced in this reaction. So we have 3 plus charge on the right side and 3 plus charge on the left side of the reaction. Therefore, there are no electrons involved in this particular reaction. Therefore, this reaction is purely a chemical reaction in which iron 3 plus is being hydrolyzed to ferric hydroxide. In summary, we learned about writing an electrochemical or a chemical reaction in a simplified way. By applying these 4 steps, you can easily write any complicated reaction without memorizing them. In our upcoming lecture, you will learn about the basic concepts of thermodynamics, particularly in electrochemistry. Then we will apply these basic concepts to develop EH-pH diagrams of metal water systems. I will show you stepwise how you can construct EH-pH diagrams in a simplified way.